So this is a lesson out of 5.2, normal distributions and finding probabilities. So let's look at an example here on utility bills. So the monthly utility bills in a city are normally distributed with a mean of 100, a standard deviation of 12. Find the probability that a randomly selected bill is less than $70, between 90 and 120, and more than 140. So again, since it's normally distributed, we kind of use the distribution curve that we have. Now, the catch is we want to use z-scores as a strategy to solve it. So remember, the formula for z-scores was z is equal to, so z was equal to x minus x bar over standard deviation. So x minus the piece of data minus the mean divided by the standard deviation. So to the first one, we have 70 as our data spot, $70. If we subtract 100, that's our mean. If we divide that by 12, this will give us our z-score. So if I can do that, 70 minus 100, and get that answer, divide that by 12, we get a z-score of negative 2.5. So if I then go to my table, negative 2.5, that's going to be 0.0062. So if we put this into perspective, so negative 2.5 would be about here. Again, it says less than, so remember that is to the left. So that looks like there's not much of a chance of the probability being over. So our probability would be like 0.0062. So that's not much of a chance. So that's what we have there for the first one. Now, instead of doing it this way, you have a shortcut on your calculator as well that does these types of problems. So if I go to my calculator, what I can do is above ours is distribution. So if it's second distribution, the second one is normal cumulative distribution function. So that's what we're looking for, is this normal cumulative distribution. If I hit enter here, it's looking for a lower bound. The lower bound, mine defaults to negative 1 e to the 99. Well, if you look at our picture, get my graph back up here. If you look to the left, there is no left bound on this thing. Notice how the graph actually, let me make that a little bit bigger. Notice how less than 70 means the left bound, there's not one. So it's got to be some really big negative number. So what I found useful is either using negative 1 e to the 99, or if you want, just use a really big negative number like negative 10,000. That usually works. So it's going to be our lower bound, the negative 10,000. Our upper bound is the 70 was our upper bound. So we can't go past 70. So less than 70. So our upper bound was 70. So slide that over. 70 becomes our upper bound. Our mean was given as the 100. And our standard deviation was given to be, 12? So if I hit that enter, if I paste it, hit enter. So my lower bound is negative 10,000. My upper bound is 70. My mean is 100. My standard deviation is 12. If I hit enter, notice how it gives me 0.0062. It gives me the same answer without actually having to do the z-score. It kind of does it for us. So there's kind of a shortcut here. So if I look at the next example, if I want to find the probability of being between 90 and 120, I don't have to find these z-scores. I actually can use the function on the calculator, the normal CDF cumulative distribution. So that's how my lower bound was the 90. My upper bound is the 120. My mean was the 100. And my standard deviation was a 12. The calculator actually can do all this for us, so we don't have to go do the we don't have to find the z-scores and then find the values off of the table. So let me see if I can do that. So if I can clear this off. So distribution is above the bars, second distribution. It's the second one. Again, my lower bound this time is a 90. My upper bound is actually a 120 this time. My mean is still the 100. My standard deviation is still the 12. That looks good. So it looks good. Hit enter. So that gives me now this point. Whoops. I can't remember it that well. So we have 0.7498, and that's going to make that, it's going to be 987,499 actually. So that fifth eight is going to make that fourth eight become a 9. So 7.7499 would be our probability. So about 74.99% if I was doing it as a percent. So let's see if we can do the next one here. The probability more than 150. So probably more than 140. So more than 140 is going to put us the other direction. So when I do the normal cumulative distribution function, what we can do is pick up on that. The lower bound is now going to be the 140. The upper bound, we can use a big number like 10,000. And then our mean was again 100. And our standard deviation was a 12. And see if that will be a big enough value there for the, since there's really no right bound, we just got to put a number in there, just a really, really large right side number. So that would be, again, 10,000 seems to work for this type of math here. So if I type in second distribution number 2 for that, my lower bound is 140. My upper bound this time is 10,000. And the rest of it stays the same. Hit enter. And that gives me, oh boy, one of those kind of numbers. So I have to move my decimal 4 places to the left. So that's going to be 3 zeros. 0.00042. So that's just going to be 4. Okay. So yeah, e to the negative 4 means to move the decimal 4 places to the left. So I need to put 3 zeros in there and then a 4. And that 2 would just make it 4. So notice how that's really a low probability. It's basically 0%, 0.04%. So unlikely to happen there. Okay. All righty. So hopefully you found that useful. And again, if you don't trust that, you can always do these by hand as well and see what that comes up with. All right. I think that concludes it there.